Alright, today's video is just a couple more examples of Pythagorean's theorem, a couple special cases. So we'll jump right into it. So remembering from yesterday, the Pythagorean theorem is only for right triangles. It is a squared plus b squared equals c squared. So for my avid kiddos out there, I've got an essential question up here for you. How do we solve for the missing side of a right triangle? And the way we do that is using Pythagorean's theorem. And again, the most important letter or most important side of the triangle is C, which is the hypotenuse. All right, so jumping right in, let's start with an example. So let's find the missing side of the following triangle. So right triangle, it's got a right angle. They're going to give us a couple sides here. 12.7 yards, 10.3 yards, and over here, let's call it X. That's our missing side. A little bit different this time compared to the other video. We've got decimals and we've got units of measure, so we have to be careful about that. Later on, our answer does have to have yards in it. We've got a right triangle, we've got two sides, we've got a missing side. Let's go a squared plus b squared equals c squared. The most important side is C, that is the hypotenuse. And in this case, the hypotenuse across from the right angle is the 12.7. A and B doesn't really matter what you call it. I'm going to go A over here and B over here. So let's plug them in. So when we're doing the math, we don't have to put yards in there, but we do in the answer need to put that. So A, you can either use the letter A or use the letter X. X is what we're trying to find, so might as well just call it X. B, 10.3. And C, 12.7. Now, since we can't really do this off the top of our head, square root decimal numbers, you definitely want your calculator nearby. So whether it's your phone or an actual calculator, go ahead and pull out that device. Now x squared is just x squared plus, let's see, 10.3 squared is going to come out to 106.09, and we're going to leave it with two decimal places. We're going to round to the hundredths today, round to the hundredths, equals, and 12.7 squared is a 161.29. Alright, we've got one letter, it's X. We want to get it by itself, we want to isolate it, so we'll move everything else. Minus 106.09, but what I do to one side of the equal sign, we got to do the other. So those cancel. X squared equals 161.29 minus 106.09 gives us a 55.2. Now that's not quite our answer yet, because if I try to write that over here, 55 is way too big of a side. We need it to be smaller than the hypotenuse, 12.7. And remember, to get rid of an exponent 2, you've got to square root. But what I do to one side, we do the other. Now obviously 55.2 doesn't really square root very well, but since our original numbers were in decimals, let's go ahead and leave this as a decimal. So 55.2, and finding the square root of that, 7 point, I've got a 429 on the calculator, so we're going to round that to 0.43. And we can't forget, yards are the units of measure. So if I put that back over here, does that number look like it makes sense? We got a 10, a 12, and 7 smaller than that side, so yeah, that number looks good. Okay, so there's one with decimals. Let's take a look at another special case. So, for example, another right triangle. Let's go 16 km, and km is kilometers. Down here 6 kilometers, and we're going to find that side there. So again, at any time, pause the video, try it ahead of me, see if you can get the right answer once I do go through it. Two sides of a right triangle, finding the third. Pythagorean Theorem. Plugging it all in. Again, C, most important side. It's always the one across from the right angle, or the longest side. So 16 is a C, A and B. Really doesn't matter. I'll go A over here, B over there, just to change things up a little bit. So plugging them in. A, we've got labeled as 6. B, X, what we're trying to find. And C, 16. These numbers aren't too bad. 6 squared is 36. X is X squared. And 16 squared, that's a much bigger number, 256. We're trying to get X all by itself. Subtract the 36 over. X squared equals 220. Again, one last step, square root. So if we go to the calculator, 220, gotta take the square root of that. It does not square root nicely. Now sometimes decimals are okay, sometimes they want you to do leaving your answers in simplest radical form. So it might be a while, it might have been a while, but we got to do the factor tree. We want to break this down into simplest radical form. So not a decimal, but in simplest radical form, depending on what the instructions say. So we want to break this down to the smallest numbers. We're going to factor tree this down. So for example, numbers that go into 220. You got a couple different options. I always make it easy and go with something times 2 if it's an even number. So that's 110 times 2. 2 can't break down anymore, but I can break down 110. That's a 2 and a 55. 2 doesn't break down, but 55 does. That's a 5 and an 11. So we've broken this down to all prime numbers. All right, we've got a 5, an 11, a 2, and a 2. And what we're trying to do is match up pairs of the same numbers. So I've got a 2 and a 2. There's a pair. The 5 has nothing to go with it, and the 11 has nothing to go with it. But we're going to take our pairs first, so I'll highlight those. We have a pair of 2's. So I'm going to write that 2, just one of them. Okay. I'm going to write the square root, because everything that's left over is going to get left inside. So we still have a 5, and we're going to multiply that to the 11 that's still there. So cleaning this up one last time, we have 2 times the square root of 55. So in the end, the simplest radical form is going to be 2 square root 55. If it says do it to decimals, that's easy. Just take 220, and on your calculator, that would come out to a 14.83. I mean, that makes a little bit more sense to us on the picture, but if it says simplest radical form, we got to use our factor tree. All right. One last example for today. This one's kind of a reversed question. So the instructions might say state if each triangle, or state if the triangle is a right triangle. So we need to find out if the picture they give us, is it going to be a right triangle? So they're going to draw it. Oops, I can do better. All right, so we've got a triangle here. Now it looks like a right triangle, but we don't know if it is yet. So I can't make that little mark there in the corner saying that it's a right triangle. They're going to give us some information. Oh my goodness, I need to go back real quick. What did I forget on this one? Kilometers. Don't forget your units. Sorry. All right. Anyways, so we're back to this one. They're going to give us 9 feet, 12 feet, and 20 feet. So just looking at the problem, if you ignore the directions, looking at the problem, it gives us all 3 sides. But we don't know if it's a right triangle yet. The thing that I know about right triangles is if it's a right triangle, the a squared plus b squared should equal c squared. That's only true for right triangles. So maybe this time let's take all those sides, plug them in, and if this turns out to be true, because we don't know yet, then it is a right triangle. If it's not equal, then it's not a right triangle. So let's find out what's what. Again, C, important side, biggest side, across from what we would assume to be the right angle. So that's going to be our 20. A and B, doesn't really matter which one you call it. So I'll go like that. So let's plug it in. So this time 3 numbers, and I do not know if it is equal yet. There's a little question mark there. We're trying to prove it. So A we labeled as 12, B we labeled as 9, and C 20. So let's just work through this like before. This time the thing we're trying to find is whether it's equal or not. No missing letters. 12 squared, 144. Plus 9 squared, 81. Again, don't know if it's equal just yet. And 20 squared, 20 times 20 on our calculator, 400. The right-hand side's done. Left-hand side, let's just add those together real quick. 144 plus 81, 225. And is 225 equal to 400? No, it is not. So I can actually go ahead and erase that. These are not equal. So again, the question is this a right triangle? If I don't get this thing equal, then no. This is not a right triangle. If the math does work out and you get 2 equal numbers, then yes, it is. But in this case, no, it is not a right triangle.